Right. Hello, welcome to the continuation of discussion with ARM processors part 4. As we mentioned, saying like to learn about any microcontroller processor, we look over learning through its features, architecture, design, then we'll go for the programming model. Now, after looking over the architecture details and register organization, working flow of ARM processor, let us have a simple look with the programming representation of ARM. Then before looking over one more speciality as mentioned in part 2, saying like it has a facility of pipelining operations, how pipelining operations happen to work out in execution. So as we are speaking of instruction executions, we would like to just focus on general procedure that is followed in instruction operation. Every instruction will be fixed up with a format or a combination called instruction codes. What are the codes we found in the instruction format is opcode and operand. Opcode is something that works on the operand. Operand is data or something that is getting operated based on the given opcode in the instruction. So what happens when will what happens inside the instruction? When will be the ALU knowing what to do with the obtained instruction? When will be the opcode highlighted in instruction? They all follow is a procedure saying like the steps of execution starting with basic design is fetch, decode and execute. Before three-stage pipelining, we had many other representations of pipelining also. Well, till now the basic pipelining is always represented from fetch, decode to execute. Going and getting the instruction is one of the procedure. Analysis of the instruction, what to do with the instruction will be decided in the decode section. Then operating the instruction will be started with ALU operations. We consider it as execution. So this is the step, this is the procedure happening. Inside this is represented as fetch, decode and execute. Three stages of instruction execution where one of the instruction is fetched, then it is decoded. While the first instruction is getting decoded, second one might be fetched. This is pipelining example. When the first one is getting executed, second one could be decoded, third one could be fetched. So at a time, multiple instructions can be concentrated by the CPU, by the controller or by the processing unit. Still, it doesn't say like it is a multi-operating device like microprocessor. These are all strategies of working with the ALU. This is ARM 7 version 3-stage pipelining. In the next level, we show the same execution unit is further divided as after execution, it has to be sent to some storage, either memory or IO. This is again stored in different ways, saying like when one instruction is fetched, when it is getting decoded, next one is fetched. When the first one is executed, second one is decoded, third one is fetched. When it is been sent out from these stages, first one is given to the location destination, making ready the next instruction for buffering to the destination, executing the third one, decoding the fourth one, fetching the fifth one. At a time, 5 instructions in a clock cycle could be concentrated, and this pipelining will be showing its importance based on the version development. Now we can see similarities. This also has TDMI arrangement. This also has TDMI arrangement. So these are some of enhancements, some of specialities we would like to always focus on one microcontroller to other microcontroller. So similarly, the programming model of ARM is also having its own prominence, a set of addressing mode and set of instruction set. A simple arrangement is represented. Somewhere again the sheet of set of instructions, set of thumb instructions shall be shared by us. Before that, a generalized addressing procedure always goes as immediate addressing mode, register addressing mode, memory addressing mode, indirect addressing mode, multiple ways of indirect addressing mode, implied addressing mode, and some set of categories of instruction set like data transfer, arithmetic, shift and rotate, logical operations, branching operations, bitwise operations. All these stand under some routine representations, as we have heard with our earlier lectures. Same headings, most of the headings will be repeated with respect to ARM arrangement also. The representation of things are also shown in format of word, half word and byte here. If the controller is working on a very normal case, saying like a word, if it is working at a basic level, saying like it can work on 8-bit data also with the same efficiency. It can work on more than 32 bits also with the same efficiency. Whenever we are utilizing a confined, or whenever we are utilizing a standardized instruction set, we consider it to be a thumb instruction set arrangement. So in some of the embedded applications, we don't require heavy set of instructions for our operations. At that time, most of the programming instructions will be relaxed. They are not being searched, they are not being decoded. This facility makes the controller to save some time in execution. At that time, only some selective instructions will be utilized. Such arrangement is provided with the thumb instruction, and this uniqueness is again making some importance for ARM processor. So as like our Java bytecode arrangement, here also we'll be having this Jazelle facility to convert our compiled data into bytecodes. That will be making easier to the compiler for operations. Different data types of instructions as mentioned, various types of operations that can be performed on the instructions. So that will be the concentration we can make with the ARM processor theoretical part. Sometime we will practice with some application instructions of ARM processors. Thank you. That will be the end of discussion on ARM processors.